Hi, good day to all my Form 4 students. Today we are here to continue on the chapter Acid, Bases and Salts, chapter 6, Chemistry Form 4. And today we are going to do on part 10. And mainly, teacher going to continue on what I discussed in part 9 of this chapter's video, which is salt. Okay, so again, teacher would like to highlight that I am not here to repeat on what has been said in all your textbooks and reference books regarding salt. Okay, if you watch my video, teacher will teach you mainly on how to conquer the pattern and understand the pattern so that you can understand salt, this chapter of salt. Alright, okay, now so previous video we stopped at part 9 of our video. Teacher stopped at preparation of salt. Okay, so a previous video teacher introduced part 9 video. I introduced you on what is the meaning of salt. What are the 4 types of salt that you will learn in your syllabus? Chloride type of salt, which you can prepare using hydrochloric acid. Nitrate salt, which you can prepare using nitric acid. Sulfate salt, which you can prepare using sulfuric acid. And carbonate salt, which you can prepare using hydrogen carbonate acid. Okay, so now and we already discussed the 2 important division of salt, which is soluble and insoluble. So in this video, teacher going to concentrate on 2 main subtopics for salt, which is preparation of salt, okay, and also action of heat on salt. Again, I'm reminding you that I'm not here to repeat on what has been said in your textbooks and reference books. Teacher will discuss mainly on the pattern for you to understand salt. Alright, now if you watched, I hope you have watched my previous video part 9. Only then you can understand what teacher explaining in part 10. So please watch my part 9 video before you come to part 10 video. Alright, okay, now so let's go to preparation of salt. So if you want to prepare, now a question is asking you to prepare a salt. Okay, so when you want to prepare a salt, if you watched my previous video, I told you that salt, we have 2 types of salt, which is soluble and insoluble. And insoluble. Okay, now in this salt, teacher will tell you, I told you in part 9 video that insoluble salt, you have 2 categories which is involving sodium ion, potassium ion and ammonium ion. Okay, this is actually our point 6. Point 6, if you watch part 9 video, the point 6 was discussing this. And a salt which is soluble but does not involve sodium ion, potassium ion and ammonium ion. Okay, now so very easy is if the salt involves sodium, potassium and ammonium ion, I told you all titration method. Titration method. Okay, so titration method is explained in part 8 of our video. Okay, so all continuity. If you really watch my part 1 up to part this part, you will find there's a continuity on this chapter. Alright, so I hope you understand what is titration method, where acid and alkali is mixed in order to produce the salt. For instance, I give you one example. Teacher would like to prepare a salt called sodium sulfate. Okay, sodium sulfate. Okay, now you saw the word sodium, correct? So now immediately you know that anything to do with sodium, potassium, ammonium is soluble, correct? So automatically your eyes must go here. Okay, and since it's involving sodium ion, the method used is titration. This is how you identify. And now I want you to suggest a salt which can bring me sodium ion, an alkali which can bring me sodium ion, and a substance which can bring me sulfate ion. So remember in our part 9 video, teacher told you in order for you to prepare sulfate salt, you will have to use sulfuric acid. Okay, so sulfuric acid is used and alkali alkali. Titration method involves alkali. Please remember that. Titration method is a type of neutralization method titration is actually a method which involves neutralization process. Titration is a setup of apparatus, so it's a method. Okay, so neutralization is a process that happens inside the conical glass. Okay, so what happens is, now I want an alkali to bring sodium ion for me, so of course I will choose sodium hydroxide. Okay, so sodium hydroxide, so might as well I just change this to color so that you can understand. Okay, so can you see that sodium sulfate, so you get sodium sulfate here already, so the rest will be easy, where you will produce water. Okay, so let's balance this. So guys, let's balance this. Okay, so you will produce water. So can you see that this is how you determine what acid and what alkali can you bring in order to prepare a salt called sodium sulfate. Okay, teacher give you another example. Teacher would like to prepare. Okay, so I hope you can understand. So in order to prepare sodium sulfate, you just hear the word sodium. The moment you hear the word sodium, you know it's soluble. So your eyes must automatically go here instead of here. Your eyes will go here, and since it involves sodium ion, you will go to this method. Alright, so let me give you another example. Okay, I give you another example. Every discussion, teacher will give you 2 examples, because here when I give you more examples, you can understand better. Okay, now so see, teacher would like to prepare ammonium chloride. Okay, so ammonium chloride. So what is, if you look at if you watch part 9 video, what is the rule for ammonium? All salts are soluble as all sodium, potassium and ammonium salts are soluble. So what you get is, I want someone to bring ammonium, so I use ammonia, and I want someone to bring acid, chloride ion for me, so teacher use hydrochloric acid. So I combine all this to get ammonium chloride, and the method will be used in order to prepare this soluble ammonium chloride is titration method. Okay, so I hope you can understand. So this is how you understand and identify. Once you identify the pattern, you can understand the pattern, solve will become actually easy. Alright, now so let's continue on second category. Okay, so I hope you can understand. Please write it down. Okay, please write it down. This goes into this category. Right? Okay, now so let's go to, now I want to prepare a salt which does not involve sodium, potassium or ammonium ion. But obviously this salt is a soluble salt. So that is the reason why you have few methods which you can use, which is adding solid reactant to acid. So you have few methods here. So first method is you add acid and metal, which will produce salt, and hydrogen, acid, metal oxide plus acid, you get salt and water, acid plus metal carbonate, where you produce salt, water and carbon dioxide. So that's the only difference here, where you add anything to do with carbonate ion. Please remember that anything to do with carbonate ion definitely will have carbon dioxide as a product. Why? Because your carbonate ion is actually not very stable. It prefers to be in the form of carbon dioxide. So that's why anything that has to do with carbonate ion, you will find carbon dioxide as one of the product. Alright, now let's go here. So see, if teacher want to prepare any salt that does not involve acid, metal, if teacher want to prepare a salt which does not involve sodium, potassium and ammonium ion, but you know that it is a soluble salt, you can use either one of them or maybe two or more method. For instance, teacher would like to produce magnesium sulfate. Okay, so now, so guys, you know that magnesium is not in this category, but you know after looking at watching teacher's video part 9, you know magnesium sulfate is a soluble salt. All sulfate salts are soluble except for calcium, barium and lead 2 sulfate. Okay, so now, so since magnesium sulfate is not in the insoluble category, it will be insoluble category, but it will go into category B. Can you see? The teacher label this as A and B will go into this category. Now, from here, you can choose what method you can use. Okay, so now, teacher will use, okay, now I want someone to bring magnesium for me, and since remember teacher told you in order for you to bring sulfate ion to produce salt, you have to use sulfuric acid. So I will bring sulfuric acid. Okay, so sulfuric acid. Now can you see that you automatically went into this category? Can you see you automatically went into this category, so the byproduct will be water. Sorry, not water, hydrogen gas, sorry. So now can you see that this is one way to produce magnesium sulfate. Okay, and please remember one thing teacher would like to highlight. This method can be used to produce any metal that involves zinc, magnesium and aluminium. Why? Because these are reactive metal. Please don't use this method to produce copper, anything to do with copper salt. Why? Because copper metal is unreactive. So that is the reason why if you are dealing with magnesium, zinc or aluminium metal, you can use this method. Okay, now another, okay, now if teacher don't want to use this, I can use another example, which is I use magnesium oxide, metal oxide and acid to produce magnesium sulfate and water. So can you see how teacher just added? So that is the reason why sometimes certain salt you have more than two ways to produce, sorry, more than one way to produce. Okay, so more than one way to produce. So these are one example that teacher have given you. Alright, okay, so write it down so that teacher can give you another example of a preparation of a salt. Okay, so you write this down. Okay, now let's go to a next question of teacher. How can I prepare a inactive and unreactive, not inactive, sorry, unreactive metal, a salt for unreactive metal. Okay, so example of unreactive metal can be lead to oxide. Okay, I'm sorry. An example of unreactive metal will be lead metal, iron, or also your copper metal. So teacher will just say, for instance, teacher would like to produce F iron to nitrate. Okay, teacher want to produce iron 2 nitrate. So can you see iron 2 nitrate? It's not a iron is not a very reactive metal. So I cannot use this method. I can maybe use this method will be more suitable. Why? Because iron 2 oxide exists as a powder. Okay, so you can put it inside the acid. So I need someone to bring nitrate ion. Of course, I will use nitric acid. I want someone to bring iron oxide, so I teacher use iron 2 oxide. Okay, iron 2 oxide in this method, just say teacher use iron 2 oxide. So can you see iron 2 oxide with nitric acid produces iron 2 nitrate and water. Okay, iron 2 nitrate and water. So this is how you produce, but it is a soluble salt. Why? Because, but it will go into category soluble, it will go into B category. From here you choose mix and match and choose. Okay. Why? Because iron to nitrate, all nitrate salts are soluble, so you have no doubt about it. Alright, now teacher give you another example. Let me give you another example. Copper to oxide. Okay, so if teacher want to produce copper to oxide, copper to nitrate. So copper, I use copper to oxide in nitric acid. So I get copper to nitrate. So this is how you, now see, so copper, iron, lead. These are unreactive metals. So this method will be more suitable. This method will be more suitable. Okay, now so let's go to, if I want to produce acid plus metal carbonate, you can. Okay, so you can, so teacher will give you another example where you use acid plus metal carbonate. Okay, acid plus metal carbonate. Okay, acid plus metal carbonate. Just now you use metal oxide with acid. Now acid plus metal carbonate. Katakan, just say teacher want to produce zinc sulfate. Okay, zinc sulfate. Okay, so I can use sulfuric acid. Okay, and metal carbonate, magnesium carbonate. This can be done. Okay, magnesium carbonate, I add with zinc carbonate, zinc carbonate plus magnesium sulfuric acid to produce zinc sulfate. So you get water, just follow here, and you get carbon dioxide. Okay, so as what I told you, carbonate ion is not very stable, so it will try to become carbon dioxide form. So can you see what has happened? Zinc sulfate, then you produce water and you produce carbon dioxide. So now you know that reactive metals, sometimes you have three ways to produce. If I want to produce zinc sulfate, I can use acid plus method. I can use metal oxide plus acid. I can even use acid plus metal carbonate. So you have three ways to produce a certain salt. But please look whether the salt is a reactive salt or not. Sorry, reactive metal or not. Please look at that. So let's go to insoluble salt. Okay, so I teach you the easier way for you to produce insoluble salt. Now, let me give you one example of insoluble salt. Okay, so one insoluble salt is lead to chloride. Now, teacher want to produce lead to chloride, so the method I can use is double decomposition method. That's the only method. You have no other way. Okay, that's the only method. You have no other way. So, double decomposition method is a method to produce insoluble salt, no matter whatever type of soluble. There might be a unreactive metal or reactive metal, doesn't matter. The moment it is insoluble, you straight away, your eyes will be straight away going here. So can you see all chloride salts are soluble except for argentum chloride and lead to chloride. So I teacher show you one easy way. Okay, easy way. So you want to produce lead to chloride. So what I do is teacher straight away write lead to chloride and must write the word S. Guys, S shows that it is insoluble, is a form of solid which does not dissolve in water. If teacher write aqueous, it means that it is soluble in water. Alright? Okay, now so lead to chloride in the form of solid, that shows that it is insoluble. Because when you look at any chemical equation, if you want to find the insoluble substance, just look for the word S here. S shows that it is precipitate. Okay, precipitate. Okay, shows that it is precipitate. Now, I want, see, double decomposition method tells that you must have two aqueous solution in order to produce at least one insoluble salt. Teacher repeat, double decomposition method says that you must have two aqueous solution combined to produce at least one insoluble salt. One insoluble salt. So that is the reason why now your task is to determine which soluble salt can bring lead ion for me, and which soluble salt can bring chloride ion for me. Right? So can you understand this? Why? Because the double decomposition, the one of rules is two soluble salt, not acid. Please remember, it's not acid. The moment you're talking about acid, that means you're talking about this category already. Okay, so two soluble salt. Double decomposition method talks about two soluble salt which can produce one insoluble salt. Now, see, so this is where your part 9, remember our discussion on part 9.5 comes in handy. Now, amongst the N ion, who is the most soluble ion? So if I were you, teacher will choose nitrate ion. Why? Because you know for sure all nitrate salts are soluble. Alright? Okay, now for cation ion, remember point 5. Cation ion, who is the most soluble cation ion? Anything to do with potassium, sodium, ammonium ion are confirmed soluble. Can you see? Okay. So they are confirmed soluble. So in this case, maybe teacher choose sodium chloride. So what happens is lead 2 chloride. Okay, lead 2 chloride. Let's balance this first. Let's balance this. Let's balance. Or else you get confused. Okay, so lead 2 chloride, lead 2 nitrate. With sodium chloride, we produce lead 2 chloride. And can you see this red color? So that one teacher just combine it into 2 sodium nitrate. Okay, now you don't have to worry about sodium nitrate. Why? Because it is super soluble. Sodium ion soluble, nitrate ion also soluble. So you don't have to worry. It's super soluble already. Okay, now so can you see how teacher produce? I produce a insoluble salt using 2 soluble salt. Okay, so remember this is not acid. You cannot use acid for double decomposition method. Alright, so now so please write it down and teacher will give you second example. Okay, teacher will give you second example, which is teacher would like to prepare barium sulfate. Can you remember about barium sulfate? Is it soluble? All sulfate salts are soluble except for calcium sulfate, barium sulfate and lead 2 sulfate. Okay, so that is the reason why our part 9 video point 5 and point 6, they are very, very important. Alright, so teacher would like to produce barium sulfate. So which you bring someone, please bring someone for barium, and I need someone to bring sulfate ion. And the rule is they must be soluble. So what teacher will choose is, of course I will choose barium nitrate. Why? Because it's very, very soluble. If your foundation in this salt is quite shaky, oh never mind, don't worry. Just remember nitrate ion. Okay? And remember the cation ion who is soluble, potassium, sodium and ammonium. Here teacher would like to use potassium sulfate. Okay, potassium sulfate. So can you see barium sulfate has produced precipitate and teacher produced 2 potassium nitrate. Okay, nitrate. So can you see this? So this is how you produce insoluble salt using double decomposition method. Some books they use precipitation method, no problem. Okay, it's the same. Alright, so I hope you can understand how to produce soluble and insoluble salt. If you're not very clear, go ahead, watch my video, repeat my video a few times so you can get the grasp of it. Okay, grasp of it. Alright, now let's go to second important subtopic, which is action of heat on salt. Which is now we are going to heat up few salts. We have 4 types of salt. Amongst that, ammonium salt and chloride salts are very stable. They don't decompose easily. Okay, so that is the reason why we only have carbonate salt and nitrate salt. Okay, carbonate and nitrate salt. Okay, which can decompose. Even that, please remember, potassium and sodium salt sometimes are very stable. They don't decompose. Like for carbonate and nitrate, potassium and sodium, they don't decompose easily. So that is the reason why teacher here going to concentrate on the famous ones which are very frequently asked in questions. Now, carbonate salt. Let's start. Carbonate salt. One thing, carbonate salts, teacher have told you all before that carbonate ion is not stable. Okay, carbonate salt is not stable. So always remember, when anything to do with carbonate salts, you will definitely have carbon dioxide. So that is the reason why here you can find that. Okay, now please remember, from here to here, why teacher divided is because this is one observation for only carbonate salt. This is one observation for only nitrate salt. So carbonate salt will produce gas bubbles which turns lime water chalky or cloudy. So when you have, this is observation, these are all observation. Okay, so now when teacher draw like this, that means this observation is exclusively for carbonate salt only. When teacher draw like this, that means this observation is exclusively for nitrate salt only. And please remember, when teacher did not do anything, that means this observation is common for both carbonate salt and nitrate salt. Again, I draw like this, shows that this is exclusively for carbonate salt, exclusive only for carbonate. This arrow shows that this observation is exclusively just for nitrate salt. But this from here to here, that is actually common observation that you can use repeatedly for carbonate and nitrate salt. So let's start. So carbonate salt can be heated up to produce. Okay, so carbonate salt, when you heat up, okay, this is how you write, you get metal oxide and carbon dioxide. Okay, so guys, so can you say carbon dioxide? When you look at carbon dioxide, your eyes will be automatically going here. So how do you test the presence of carbon dioxide? Using lime water. You'll be learning these things from 1. Okay, presence of carbon dioxide can be tested using lime water. Now, let's discuss on nitrate salt. Okay, so nitrate salt, when you heat up, you'll be surprised to find you have 3 products, which is metal oxide, nitrogen dioxide and oxygen gas. This is exclusively only for nitrate salt. When you heat up nitrate salt, you get metal oxide as a residue. You see a residue, okay, nitrogen dioxide and oxygen. Now see, what happens is you have 2 gases, correct? So the observation for 2 gases is for nitrogen dioxide, brown gas, and for oxygen, colorless gas. Okay, for instance, when salt is heated, okay, when a salt is heated strongly, a brown gas and a colorless gas is produced. So what I want you to remember is the moment teacher mentioned the word brown gas, look at the observation. Gas bubbles, colorless. Okay, colorless gas bubbles. Okay, this is residue, this is solid, you don't need to worry. Now brown gas, can you see brown gas is at nitrate salt. So you know the anion involved is nitrate ion. So this is how you identify. Okay, and oxygen gas is another product, but since it's colorless, usually we will highlight on brown gas. So when the moment you have a brown gas as one of the product, definitely involves nitrate salt. When you have a gas which changes lime water to chalky or cloudy, That means you know it contains carbonate ion. Okay, now residue will determine which cation are we talking about. Okay, now so please remember you have two types of residue, which is white residue and colored residue. So here teacher discussed the more frequently asked questions. Okay, so that here I'll teach you the pattern again. Teacher here to teach you the pattern, because all this information you can find in any reference book or textbook, no problem. But here I'm teaching you the pattern. Alright, now if it involves white residue, if it says white residue, it involves calcium oxide, magnesium oxide and aluminium oxide. You might be wondering, teacher, what happened to potassium and sodium? They are stable. They cannot decompose. Okay, so anything to do with white residue, calcium or magnesium or aluminium oxide. Now, because white metal residue is this, what I meant by metal oxide, the residue. Okay, now common observation for carbonate and nitrate salt. So common observation now, this is the famous ones, which is colored residue. So zinc oxide has a color where it is hot. When it's hot, it's yellow. When it's cold, it is white. Okay, so teacher repeat. Zinc oxide is a residue which is yellow when hot, white when cold. Lead oxide is a residue which is brown when hot. When it's hot, it's brown. And when it's cold, it's yellow. Okay, when it's cold, it's yellow. And copper oxide is one metal oxide which is black in any color. Sorry, in any state, not any color, any state. Hot or cold, it is black color. Alright, and the common, then after that, what I want you to do is, in order to identify the metal that has been heated, you have to attach this observation or this observation with this observation. Teacher repeat, in order for you to determine which salt has been heated, you have to attach this observation or this observation with this observation. I give you one example. Okay, when a salt is heated, teacher give you one observation. Salt is heated to produce a colorless gas and brown gas. So these are, just look at the observation, colorless gas with brown gas with residue which is black. Okay, a residue which is black. Now, can you identify the salt that has been heated? So in order for you to determine the first, look at this colorless gas and a brown gas. So look at these two observations. Exclusively for carbonate salt. This observation exclusively for nitrate salt. Can you see you have a brown gas? So this confirms that it has nitrate ion. Don't worry about the colorless gas, because oxygen is not very significant in order to identify as observation. Now, let's go to the residue. When you are looking at residue, remember teacher told you this from here to here, common observation for carbonate, common observation for nitrate. Now, can you see color? That means you go to color and look at black. So that means it shows that copper to oxide. Now, can you identify the salt for me? Copper to nitrate. Okay, so can you identify copper to nitrate? So this is how you identify the salt which has been heated. Okay, so teacher repeat, whatever I wrote here exclusively for carbonate salt, whatever I wrote here is exclusively for nitrate salt, but the residue, the color of the residue is common for both carbonate and nitrate salt. So when you look at a certain salt which has been heated, the color of the gas or the characteristics of the gas will give away. Okay, will give away the type of salt. Okay, characteristics of the residue and the color of the gas, or maybe the characteristics of the gas itself will give away what salt has been heated. Now, let me give you another example. Okay, so let me give you another example. Okay, so this is again, it's all about understanding the pattern. Once you understand the pattern, it's okay already. Alright, so when I heat up a salt, I get a colorless gas that changes lime water to cloudy, and a residue which is yellow when hot, white when cold. Okay, when I heat up a salt, okay, I get a colorless gas which changes lime water to cloudy or chalky, and I get a residue which is yellow when hot and white when cold. Now, when you're looking at the colorless gas, your eyes must go either here or here. So, who has colorless gas? Of course, colorless gas, but I did not mention the word lime water. So, your eyes must go here. Can you see you have lime water? So, this shows that obviously this color has carbonate ion. You understand? It has carbonate ion. Now, residue. Can you see the common observation for residue? Color. Can you see yellow, white, color? Correct? Okay, so that is the reason why go for color and look for yellow when hot, white when cold. So that is the reason why this is zinc oxide. So this shows that the salt that has been heated is zinc carbonate. Right? So can you, it is easy for you all to identify. Yeah? So this is how you discuss, or not to say discuss, this is how you identify a salt when it's going through action on heat, and this is how you prepare a salt. Okay, so again, what have I taught you is all the patterns to understand this chapter. Alright, so we'll continue our video on part 11 on how to identify gases, how to identify anions. Okay, so part 11, we will identify gases and we will identify anions and their respective uh, their respective uh, uh, um, tests to test the presence of a anion. Alright, okay, so teacher will stop the video here. Thank you for watching. We will continue on next video. See you all.